Hello and I welcome you all to my video classes on water harvesting and conservation. We'll see the today's content. So in this video we are mainly dealing with rainwater harvesting techniques related to rural area. So mainly we are discussing about what are the different techniques related to rural area. So and why it is a rural area, that we are discussing in introduction part. So then we are discussing various techniques related to rural area. So now first we'll understand what you mean by rainwater harvesting. So already I explained in previous lectures, rainwater harvesting is mainly related to collection of rainwater, storage of rainwater and reuse of rainwater runoff, right? So this is what our main motto. But here we are making classification, because separate techniques for urban area, separate techniques for rural area. Why? Because some limitations and some advantages. If you see the limitations, right, some problems, it required simple and low cost techniques for rural area. So what is the condition? Simple technique and low cost technique, right? That is what one concerned. And when you are fulfilling the simple technique and low cost techniques, then we can adapt for this rural area. So then is requirement of minimum specific expert knowledge, because of less skilled laborers and because of less known persons. It required minimum specific expertise and knowledge, right? So then it should offer many benefits. From single work it has to benefit for many work. For example, when you are making rainwater harvesting, it has to impact on drinking water, it has to impact on irrigation, it has to impact on the other conditions or environment, right? So it has to offer many benefit. Next is advantages. So in rural area we are getting some advantages. One is large quantity of water you can make the groundwater recharge, right? So huge quantity of rainfall is coming, and even it is a pollution less. Comparatively urban area, rainwater from rural area is a pollution less and less contaminated. So that's what we can make easily groundwater recharge with a good quantity. So then large space is available. Open large space is available in rural area, and even the cost of the land is also less comparatively. So that's what we are going mainly for surface spreading. So in this we are not because of space availability, mainly we are focusing on surface spreading techniques. And some of the common techniques are there. If you go for common techniques, even they know it based on the some conditions, right? Here I taken some 11 techniques. So first one is terrace method, we'll discuss. Next filled trench method, cisterns method, micro catchment, and rooftop harvesting, percolation tank, check dam, farm pond, groundwater dams, afforestation, then consumptive use. So I think you not studied what you mean by conjunctive use. So conjunctive use means it is what balanced use between surface water and groundwater. So what you mean by conjunctive use? It is balanced water use. B. You just you remember balanced between groundwater as well as surface water. So from that we can overcome the shortage of water. So then we'll discuss one by one. These are the list. Like you may get a question like list and explain the different techniques related to rural area. So now we'll explain one by one. So one is terrace method, or even it is called as a contour bund, right? I think we studied in generalized techniques of rainwater harvesting. Here also same techniques we are using if it is a land is a sloped land. So then quick runoff will be there. To tackle the quick runoff, we are constructing some bund and we are excavating along the contours. Even you can see in the image, right? You will see many contours and how cropping is taking place, and as well as storage of water. So from here you will get a good cropping as well as soil moisture, as well as water conservation, and as well as soil conservation. And even in the cross section we can see, right, here a plantation is there, means contour can be used for plantation, or even we can use for cropping also. But small bund is constructed, right, along the contour, and even you can see some ditch holds water on the contour. So here water is holding because of the some structure, right? So here if you see the principle of how it is working, so here mainly is by building bund along the contour line. So here what we are doing, we are doing the construction of bund along the contour. Even you can see here, right, construction of bund along the contour. Here color difference is there, dark color and pale color, right? So dark color indicates the construction of bund along the contour, right? Then water runoff is slowed down, and due to this construction and because of storage of water, velocity of the water surface runoff slow down, which leads to increase the water infiltration. When velocity is reduced, it causes the come down, it leads to increase the infiltration, then enhance the soil moisture, right? So when standing water is there, right, due to the standing water, infiltration will takes place. So due to the infiltration, definitely it will make groundwater recharge. Then bunds are usually constructed either with a soil or stone. So bund are constructed with the soil or with the locally available stones, and distance between the depends on the slope and type of the soil. The distance between one bund to another bund, or one terrace to another terrace, it mainly depends on the type of the soil, right? So we have different types of soil, and even it depends on the slope condition, steep condition, medium, flat, right? And then even we are using these techniques for cropping as well as plantation of trees. I think you understood, very simple topic. Just we are constructing bund, or we are making contour farming, and by constructing the small bund along the contour, right? And the main thing is what we have to tackle the runoff of rainwater runoff, and by storing the small amount of rainwater in a ditch, right, it is called as the contour bunding or terrace method. So we'll see for next method now. So next method is filled trenches. So filled trenches, basically trenches can be seen as a extensive plugging to the right angle to the filled slope. For example, here it is what we are excavating some material. If for example it is a land, so for this land, right, so it is what land gradient, and perpendicular to the surface we are excavating the material. And due to the excavation of material, right, there is a ditch formation, a trench formation, and due to this trench formation along the wasteland, or like a hilly areas, we can collect the water. That's what they're telling. Basically trench can be seen extensively flogging to the right angle to the field slope, then breaking the slope and therefore reducing the velocity. So here also we are mainly focusing on reducing the velocity of water runoff, reducing the soil degradation and erosion, enhance the infiltration of surface runoff, right? So here what are the main focuses? First we are reducing the velocity of the rainfall runoff, then due to the reducing the velocity, it makes the, and even because silt deposition and even soil degradation, so it is reduces the erosion as well as soil degradation, and after that infiltration, and mainly it is causing for infiltration, and due to the infiltration we are getting soil moisture condition, right? So then fill trench suit most soil and rainfall condition. Here also trenches are suits for most of the soil, not all kind of soil, and as well as all kind of rainfall conditions, even for dry condition, even for more rain condition. If it is a less rain condition or dry region, then we can suggest for continuous trenches. Here you can see in the figure, it is what continuous trenches along some length. And if it is a more rainfall, or we can, we are getting more rainfall, then we are going for interrupted trenches. So just I will repeat what you mean by trenches. Trenches are the excavation of the material at the right angle to the field slope, then, and due to the excavation of the material from the ground, it has collecting the water, and due to the collection of water, velocity of the surface runoff is reducing. Due to the velocity of surface runoff reducing, it causes the infiltration, and due to the infiltration we are storing the water under the ground, right? It is mainly related to soil conservation as well as water conservation. And one is, if it is a dry condition, we are going for continuous trench methods. If it is a more rainfall, then interrupted. So this you can understand by this image. Here you can see some of the disconnected trenches, right, where we are constructing these kind of trenches where we have a more rain, and continuous trenches where we have a less rain, right? Here you can see bund is there, trench is constructed along the contour, and water is collected, right? So now we'll see for next method. So next method is cisterns method. So you can see cisterns is an underground tank that holds the water. What do you mean by cisterns? Cisterns are the underground tanks, and through these tanks we are storing the water. See, you can see in the image here it is a opening of cistern, right? It is one of the olden and very old tank which is there in European countries, quite common in European countries, right? So here it is underground tank, right? And why we are constructing the underground tank? To just store the rainwater. Cisterns are often built to catch the or catch and store the rainwater. So here it is built for catch and store the rainwater. And what do you mean by catching and storing? It is rainwater harvesting, right? So then it has some different characteristics with the well. Why? Because it has a waterproofing along the wall. And in modern days, right, capacity of the cisterns are different. It is like few liters to cubic meters, and cisterns were used for domestic as well as agriculture purpose. So even we are using for domestic purpose, maybe for cleaning purpose, cleaning of cloth, using for gardens, right? Even you are using for drinking water after the filtration. As I told, even we can use a rainwater for drinking purpose after the filtration of water, right? Proper filtration and maintaining the standards of a drinking water standards, then you can use for drinking also. Just I'll repeat, cisterns means what? Underground tank. And what is the main purpose? To store the water and to catch the rainwater. Then it has a different from the well, it is not related to well, right? And we are using for domestic purpose as well as agriculture purpose, right? I think you understood. Even you can see under the ground, these are the these are the storage areas. It is a opening, and it is, you can see under the cross section or some inside how it is there, it is like a just underground tank, right? And these are the quite common in European countries. Next is micro catchment. So micro catchment we already studied in previous lectures, right? So what do you mean by micro catchment? Micro catchment is specially prepared area. Micro catchment is specially prepared area with a slope and berms. With a slope and berm. It is what? Slope, and this one is a berm. Berm means just like a some road like a structure, right? So berm designed to increase runoff from rain. So to increase the runoff, see the runoff from the rain, and concentrated towards the planting basin. So where we are making mainly, it is what? Specially designed with a slope and burn. And what is the main intention? To increase the runoff towards the plant. You can see here catchment runoff is there, runoff is going towards the plant. So here you can see some rainfall with the arrows, and with bigger arrows is showing the runoff towards the plantation. Why it is going towards the plantation? Because it is specially designed with a slope and burn, right? So then when you are focusing towards the plantation, it causes the storage of water through the infiltration, where rainwater infiltrates and it's effectively stored in a soil profile. So here it will store in a soil profile. It causes the less evaporation losses, and it will gives the more water throughout the year, right? So next is the water is available to the plant, but protection from the evaporation. So water is available through this, water is available for plant, but evaporation will be less comparatively with other method. Then micro catchment system provided many advantages over, right? It has a many advantages over the other irrigation schemes. Why? Because micro catchment we are using mainly for some plantation purpose or some some different agriculture purpose. Even you can see here it is a small catchment along the terraces, and even you can see rectangular small catchments and semicircular micro catchment, and it depends on the locality and depends on the material. So you'll get more idea by this image, right? You can see this, it is what exactly how they are constructing on the ground, right? These are the quite common in some of the places, right? So here you can see there is a plantation, a tree. Around the tree they constructed the half moon or oval shape or half oval shape of bund or burn, right? So main is to collect the water, and even you can see it is what? V shape of the catch with the locally available stone. So what do you mean by micro catchment? Micro catchment are the small catchment are constructed mainly to collect the rainwater, right? Very simple is what? It is a what? Small catchment which is helping to collect the rainwater towards the plant zone or towards the plantation, right? So next method will go, so percolation tank. Even percolation tank also we studied in previous lectures, right? So mainly it is related to percolation of water, right? It is defined as an artificial reservoir which are constructed across the stream, it is like a tank. One of the tank is constructing across the stream or across the nala, right? A land area with the adequate permeability, right? Adequate permeability to facilitate percolation to collect the surface runoff water. So what is the condition? It is artificial reservoir, right, constructed across the stream and with a place with the high permeability. Why we require high permeability? Because it has to cause the percolation. So mainly because of percolation we required highly permeable land which has a weathered zone and fractured and highly percolated area, because percolation has to be maintained, right? So this is what called as percolation tank. Even you can see it is on the ground. These kind of structures are quite common in India and some south part of India. And you can see cross section, right? Here bund is there and water is stored, and even excavation of the ground is made, and due to this water is making groundwater recharge or percolation because of weathered zone and highly permeable material. And size of the percolation tank mainly depends on the not rainfall runoff. Even rainfall runoff is very important, but capacity and size mainly depends on the strata condition, a bed condition, right? So then usually you have a tank of capacity of zero point 0.1 to 0.5 mcm, right? 0.1 to 0.5 mcm. Then, and one of the major problem for this percolation tank is silt deposition from the surrounding area. If is a silt is a clay material, then it definitely causes the percolation problem. So here they are telling that if it is surrounding area is with a silt content of sand, then this method is good for that locality, mainly to avoid the silt deposition at the bottom. And even they are suggesting that where we have a less silt deposition, this method is very good. And if it is a sand material around the catchment, then it is also good. So next method we'll see now. So method is check dams. So check dam is what? Small dams. Check dam is a small dam constructed across the drainage ditches. Drainage, for example, gully erosion. We in agriculture land we can see some gully erosion or removing of soil because of some channel formation. So along that we are constructing the small dam, right? Mainly across the drainage ditches or waterway to contract erosion. Mainly we are dealing with erosion of the soil by reducing the water velocity. See, it is just a barrier like a dam, but it is a small structure and we are preventing the soil from the erosion, right, and reducing the velocity. But when reduces the velocity, definitely it causes the infiltration, right, because of less velocity. Then it has related with the water harvesting, allows groundwater recharge, but level of infiltration can be slow due to the silt built up, right? It allows the groundwater recharge but comparatively less because of the silt deposition at the bed. Next is, this method allows farmer to protect themselves against the soil loss. It is protecting the soil loss. Why? Because topsoil is very fertile soil. It has rich with all the requirement of the plants, NPK. So when it has a good soil on the top, farmers can prevent by constructing these kind of check dams. Then depending on the topography, depending on the precipitation condition, depending on the material available and financial condition of the people, right, construction of check dams depends on the conditions, right? I told it construction depends on the topography, precipitation, material and finance condition, right? So here based on this we classified mainly three types. One is temporary check dams, semi-permanent check dams and permanent check dams. We'll see what you mean by temporary check dams. So temporary check dams means what? They are in a temporary condition, maybe for 1 year, 2 year, maximum 3 years. So we are constructing with the help of loose stone, locally available loose stone or locally available wood, and with some connections between a wood we are using wire or locally available some material. Even you can see here in the first image, this is what a check dam, right? It is what check dam which is constructed across the nala or stream and with help of locally available stones. So that's what is called as loose rock check dams. Loose rock check dams. And similarly here same structure will be constructed with the battens of the wood, so that's called as a batten wood check dam, right? So next we'll see for semi permanent. Semi-permanent. So semi-permanent means what? We are using the material in the form of semi-permanent nature. Semi-permanent nature means we can give earthen dam, right? Small earthen dam. We are using the bund, small bund, and due to the construction of small bund, but bund is not a permanent. It may cause the some failure. That's what is considered as a semi-permanent. And even gabion structure. Gabion structure means what? It is like a dam, right? But here it is only stones and wire mesh are used. For example, wire mesh box will be there, and that box is filled with the stones. That box is filled with the stones, right? And that constructed across the nala, same like a masonry work without mortar and without cement, right? But what is a binding material, or it is which one is giving a strength? Wire mesh, galvanized wire mesh on the surface of the stone. Even you can see in the image, this is what a masonry or stone masonry, right? With covered by the stone, entirely covered by wire mesh, and that wire mesh starts from foundation, right? That structure is called gabion structure. So next we have permanent check dams. Permanent check dam. So permanent check dam, why it is called as? Because it is constructed with a masonry, right? Maybe stone masonry, brick masonry, and even if it is constructed with the RCC, even you can see in the third image, right? That bund is constructed, or it is a dam is constructed with the help of masonry or concrete, right? It is in the form of permanent in nature. That's what is called as a permanent check dam, right? What do you mean by check dam? Small dams constructed along the nala or stream. And what is the main important? To reduce the velocity. Why we are reducing the velocity? Because we have to make less silt deposit, more silt deposition in locality, and due to the reducing the velocity, it increasing the infiltration. Next method is form pond, right? Pond is constructed, and where is constructed? In a agriculture land, right? Form pond are small water bodies formed either by constructing a small bund or by embankment across the waterway by excavating, right? So here we are making some small ditches or excavating material from the agriculture land, and excavated materials, and towards that we are supplying the rainwater. You can see in the image some excavation of material is taken place, right, in some particular size, and the locally and the local rain runoff is supplied towards the form bund, right? So even you can see, this is what just I will explain in a common general understanding. Ponds are locally constructed with the excavation or across the stream with the constructing embankment. Two types are there. One is excavating the material first, and both the image are example of excavating the material from the ground, and towards that water is diverted, natural drainage is diverted, and water is stored. One more is constructing the embankment across the waterway. So here waterway is there, maybe nala, and for that nala they constructed the embankment. From the embankment they store the water, right? That is what called as embankment constructed form pond, right? And the water usually harvested from the small catchment area, then used for irrigation for prolonged period. So here water is stored, and due to the unlining, you can see both the form pond are unlined. Due to the unlining, water is making infiltration, right? And even we are using for agriculture purpose, and it is what one of the type of technique of water harvesting related to rural area. So just I'll repeat, what do you mean by water harvesting? Water harvesting is what? Collection and storage and reuse of rainwater runoff, right? So here also we are using the reuse for agriculture purpose and for drinking purpose of cattle. That is what benefits of farm pond. So one is collect the excess runoff, right? Then store the runoff can be used for supplementary irrigation for the irrigation purpose. Then it provides the drinking water for cattle, provides for drinking water for cattle, and even it makes the soil water conservation, right? So that is what it is, one of the technique. So next, last method, right, it is a groundwater dam. See here, don't confuse with surface dam, check dam. It is what? Groundwater dam. Groundwater dam. You can see below image, right? Here under the ground, see here bore is there, right? Under the ground, ground level is here. Under the ground there is a bund, there is a bund construction. And why this bund is constructed? Mainly like similarly same surface dam, how we are constructing the tank on the surface, similarly we are constructing the bund below the ground, and mainly to store the water, mainly to store the water. You can see groundwater level, right? And we want to improve the groundwater level by constructing barrier. You can see it is what one of the example how they are constructing the concrete barrier, right? Concrete barrier. So like this we'll construct, and based on the geological study, based on the geological investigation, we'll make the barrier based on how we are making investigation, site investigation. Here also we are making site investigation, right? So that is what underground dam. So underground water dam are constructed, then interrupt, obstruct the natural flow of groundwater that provides the storage for water in underground, right? And some of the benefits, and two types are there. One is subsurface dam, one is subsurface dam, and sand storage, right? Both are the storage, but if it is a stand, right, no sand deposition is there, and due to the sand deposition water will be stored in a voids, right? That is called as a storage. And like no many places they will make subsurface dam. And what are the advantages? Less evaporation because of underground storage, right? Provide the moisture for the local, and it also increases the nearby wells or water availability by nearby the wells, and it not provides the place for mosquito breeding. Mosquito breeding means what? Some because mosquito takes the breeding on the surface of the water, but here there is no standing water. Because of no standing water, there is no any breeding of insects. Means even we are maintaining the hygienic condition and good conditions, good health conditions, right? I think you understood, right? And thank you for watching this video. Thank you so much.